In section 2, we're going to be going over how to find perimeter and area for these shapes. And I'm going to start first with perimeter, which remember is the distance around a shape. So in order to find perimeter, you need to select the appropriate formula for the shape that you're working with, substitute known values into the formula, and then evaluate the equation that you have. On these next couple of slides, I'm going to be showing you the different formulas for perimeter for the most common shapes that you'll be dealing with, so feel free to come back to these slides or take screenshots of them or whatever you might need to do. Write them down so that you have them in a easy access place. They're also fairly easy to find if you just Google the perimeter of a parallelogram or a rectangle. But you'll see the name of the shape, the formulas that you can use, an example of what a shape might look like, and then what some of those letters stand for. So if you see the letter B, it's going to stand for base, L is going to stand for length, W is going to stand for width, S is going to be for side, and then for some shapes they might use different letters to represent side. So they might actually use letters like A, C, those kind of things. But so this first one shows you the equations for parallelogram, rectangle, and square. And then the second one here shows us the equations for a rhombus, a trapezoid, and a triangle. I want to get into some examples. So if we read this one, the rear window of a pickup truck is a trapezoid whose shorter base is 40 inches, whose longer base is 48, and whose non-parallel sides are each 16 inches. How many inches of rubber gasket are needed to surround the window? So we use the perimeter equation for a trapezoid. We plug in the appropriate values, so 40 plus 48 plus 16 plus 16. The 40 and 48 are your bases, and then the 16 would be those other two sides, A and C. And then you add those together and you get 120 inches. For labeling perimeter, it's just the unit that you're working with, so it's just inches, nothing fancy yet. We'll get to that when it comes to area. Next example, the triangular gables of an apartment unit under construction are outlined in contrasting trim. If each gable is 32 feet wide and 18 feet on each side, how many feet of contrasting wood trim are needed for each gable? You can see my equation for a perimeter of a triangle, A plus B plus C. This is saying that it's 32 inches wide, and then the other two sides are both 18. So 18 is going to get used twice, so 18 plus 32 plus 18, which gives us 68 feet. Now if you're missing a dimension on a composite shape, and a composite shape would be when you have two of those basic shapes stuck together. So it could be two rectangles, it could be a square and a triangle, it could be a trapezoid and a triangle, it could be any combination of those shapes. You want to determine how the missing dimension is related to the known dimension. So one of the biggest things that you're going to want to do is try and split your shape apart into smaller shapes that are easier to deal with. And then make a calculation using those smaller shapes to help you find the perimeter of the combined shape. So it could be as simple as two small shapes, or it could be 3 shapes, 4 shapes, just depending on how much you need to break apart the composite figure. For example, if you're given something like this one and they want you to find those dimensions of x and y, what we could do is break this apart into 2 rectangles. So in order to find x, what I'm going to do is take the 8 feet 6 inches and subtract the 3 feet 6 inches. So I'm kind of looking at the taller, skinny rectangle on the left side. So I know that that full length is 8 feet 6 inches, and this little bottom portion over on the way right side is 3 feet 6 inches. So if I actually drew in the line on my rectangle there, that could be transferred over, and so just to subtract those would give you your x. So that's going to give us 5. Now we can do a similar process for y, except you look at like the skinny rectangle on the bottom. And so you're going to take 12 feet 6 inches and subtract the 5 feet 6 inches. Again, you can transfer those measurements down if you need to. That's going to give you 7 feet. For this one, they want you to find the number of feet of 4-inch stock needed for the base plates of a room that has this layout. So again, we're trying to find X and Y. So to find X, I'm going to take the 15 feet minus the 7 feet. So that's kind of looking at the big shape over on the right side. So if you can see my pointer, it's like drawing a line right here. And so I'm taking this 15 minus the 7, and that's going to give me 8 feet. And then to find Y, I can use the skinnier rectangle. So again, looking down here, if I imagine like this line being extended across, I could take 24 minus this 9, and that's going to give me 15 feet for Y. So to find the perimeter of the entire outside shape, then you have to add all of those edges together, including now the X and the Y that you found. So starting up at the top with the Y, that's 15 now, and then I'm going to go counterclockwise around the shape. So going to X, which is 8, plus the 9, plus 7, plus 24, plus 15, that gives me 78 feet. Moving on to area, you're going to want to visualize the polygon or look at the picture that's provided for you, select the appropriate formula, substitute your known values into the formula, and then evaluate it. Again, I've got slides here that have the common equations for area, so you'll want to just come back to these if you need them, screenshot them like you did before, write them down. And again, this will have all of the letters explained over on the far right side, so that if you're not sure what the B stands for again, or H, that tells you. Now the difference here is a lot of these are going to start requiring you to use height, and anytime you're using height for area, you always want to use a vertical, straight up and down side. You never want to use a slanted side as the height. Imagine if you go to the doctor's office and they want you to measure your height, they make you stand straight up against the height, or like a wall or something like that. You're never going to slouch forward or lean over to the side, because that would not be your true height. Okay, and here's the second side. There is a special area equation for a triangle that's known as Heron's formula. It's not super common that that one gets used, but I am going to show you an example of how to use that one. Alright, so let's find the area of this trapezoid. So we grab our equation. For this one, the height is 4 and those bases are 9 and 13, so we plug those in and then we just evaluate, and we're going to get 44 centimeters squared. Now for area, you always have to have the units and then square it. So you want to make sure that whatever your units are, you then have that little 2 exponent next to it. Another example here using a triangle, the height is 6 and the base is 8. So 1/2 times 8 times 6 is going to be 24 inches squared. For this triangle, the height is actually that 21. Again, remember I said that for height you want to make sure that you use the vertical segment. So it needs to be a segment that's going straight up and down. Now you can see those red dotted lines on the outside of the shape. That's just kind of showing you where the height would be. Now your base is 15, so we plug those in and we get 157.5 inches squared. Now this one is going to show you guys how to use that Heron's formula. So we first need to figure out what S is equal to, and so the easiest way to do that is to take 1/2 times the sum of the 3 sides that you have. So half of 19 plus 15 plus 8, and that simplifies to 21. So now the area of the triangle looks like this, and it looks a lot more complicated than it actually is. You're going to use S, which is 21, and then you're taking S and you're subtracting all 3 sides. So A would be like 19, B could be 15, C could be 8. So they plug all of that stuff in, and from here you just need to do some of this math, and then you'll just use a calculator to help you with that. So this simplifies to 21 times 2 times 6 times 13. Now that's all underneath the square root sign, so you want to make sure that you keep that underneath there. The final step is to square root this, and you're going to get 57.24 square units. Now we're going to get back into some composite shapes again. So this is wanting us to find the number of square yards. Notice though that your shape is in feet, so we'll have to take that into consideration at the very end here. I'm going to divide this into 2 polygons. So again, imagine that there's like a line extending where this 8 feet it extends down, and you can actually break this into a rectangle right here on the left, and this is actually going to be a square over here. So the rectangle is going to be that 9 by 7, so you multiply those to get 63 feet squared. And then the square is going to be that 15 times 15, which is 225 feet squared. To find the total area, you add those two numbers together, and we get 288 feet squared. Now, this is showing you how to convert it to yards. It's a little bit different than just converting regular feet to regular yards because it's a squared unit. So think to yourself, how many feet are in a yard? Or how many yards are in a foot, whichever way you want to go. There are going to be 3 feet for every 1 yard. Now, because it's squared, I'm going to actually take it times 1 over 9. So instead of dividing by 3, we actually have to divide by 9. That would be 3 squared, because we're taking this from a squared unit to another squared unit. So it's a little bit different there. So if you take 288 and you divide by 9, you get 32 yards squared. Now you could also have taken all those feet measurements, converted them to yards first if you wanted to, and then you would have the same answer, 32 at the very end. Another example here with a composite shape, dividing this into polygons, what I did is a triangle. So I imagined drawing a line straight across here to get a triangle on the top, and then this bottom piece is going to be a trapezoid. The base for this triangle is going to be the 23, just this measurement in the middle. The height is this 5 feet 4 inches, which I converted that to a fraction. Now how I got this is, if you think about 4 inches, that's actually a third of a foot. So you have 5 1/3, and then changing that to an improper fraction got me 16 thirds. So that's 61 1/3 feet squared. Now the trapezoid, you're going to do half times the height, which is 8. And then adding the bases. The top base is like the bottom of that triangle, which we said was 23. And then the bottom base is the 3, the 23, and the 3. And that's how I got 29. So I simplify that to get 208. So total area would be adding those two numbers together, so we get 269 1/3 feet squared. For this next one, divide it into polygons. So I did a square over here on the far right side, which is a 3 by 3 squared, so that's going to be 9 centimeters squared. Then I did a rectangle, so I looked at the 10 centimeters, which is right here, and then I kind of drew like an imaginary line here, and this top is 15, while this is 5, so this is going to be, I'm sorry, I'm talking about the 10. To get the measurement across here, we get 12 because we're going to take the 15 and we're going to subtract the 3. And so that's going to give me 12 all the way across. So I get 120 centimeters squared. And then I also have a triangle over here. So if I think about breaking that triangle out, I'm going to do 1/2 times 7 times 7. And the 7's come from taking this 10 minus the 3 to get the size of my triangle. And that's 24.5 centimeters squared. To add the total area all together there, add all 3 of those numbers, and you get 104.5 centimeters squared. Okay, make sure you guys check the homework website for the assignment link. That will be in the Google Doc. Make sure that you're submitting your assignment to me via email, and please don't hesitate to reach out if you need help on this assignment. I know that some of these problems, especially those composite ones, can require you to do a lot more deeper thinking and just make you be a little bit more creative with your shapes that you're trying to work with. So if you're finding that you find those really hard or you're not sure how to do them, please reach out. I would be happy to help you if you need that.